All right, it's 6 o'clock, so we'll go and get started. I don't see anybody on yet, but I'll go and get started anyway. Of course, I will be posting this video later, and I'll get the link sent out. So if you want to review it, then you can. Okay, so this was week 3 of our beginning Python course. So let's get right into this week's content. So the first thing we talk about this week is Boolean expressions. So what is a Boolean expression? A Boolean expression just means something that is true or something that is false. That's what Boolean means. It means true or false. It could be one of those two values. So in Python, we have a keyword called true. We also have a keyword called false. And so what are these useful for? What are these good for? Well, first of all, let's see what kind of things can be true or false. So let's start off with using some print statements just so we can get something printed out on the screen. See what's going on. So let's say, what if we print true? And then also, let's go ahead and print false. Now, these are not strings. Oops. Wrong capitalization. There we go. I'm going to print true and I'm going to print false. And when I say print true, notice this is not a string. Right? You know, a string would be like that, right? That would print the string true. That's not the case here. This is the value true, and this is the value false. Let's save this. Let's run this Python file. Python 3 file. There we go. As you can see, excuse me, it prints out true and false, just like I told it to do. But again, note, this is not the string true. It is not the string false. It's an actual value that is true. It's a value that is false. Okay. And a little bit further along in the video, you'll see why we need this true and false. All right. So let's actually see what the type of that is. Like I said, it's not a string type. Let's print out the type of true, and then we'll print out the type. Oh, goodness. And then we'll print out the type of the string true. And you'll see they're two completely different things. Save it and let's run that. You see, one is a bool, meaning Boolean. That's this one. And then you have the other one, which is a string, which is correct because that is a string. You know, it's inside the quote marks. Okay. So now that we've kind of established that, you know, this is a Boolean, it's completely different from what a string is, let's see some other things that we can do with it. So let's print. There's other let me rewind that a little bit. The Booleans are true and false. Something is true or something is false. But we can use some mathematical comparisons to determine if something is true or something is false. We could do that something like, we can use equals, right? We could say 4 equals 4. And note that I'm using 2 equal signs here. That is when you are comparing two things together. I'm comparing these two numbers together. If I use a single equals, then actually I think that may give a Python error. And it does. It says that's an error. Because when you're comparing, you don't use a single equals. You know, you use a single equals when you're assigning a variable. So if I have the variable a and it said equal to 4, you know, that's fine with the single equals. But if I'm comparing two things together, it has to be 2 equal signs. All right. So if I print out 4 equals 4, you know, what is it going to print? Is it going to print 4 equals 4? No. This evaluates to one of those Booleans. It is either true or it is false. And so we know 4 does equal 4. That is true. This should print out true. Let's run it. And indeed, it prints out true. And of course, if we say 4 equals 2, that's obviously false. And so this will print false. Okay. Equals is not all we have. We can have not equals. 4 not equals 4. So let's print those two things. So 4 not equal to 2, that is true. 4 not equal to 4, that is false, right? Let's run that. And indeed, you get the first one is true because 4 does not equal 2. That is true. And the second one is false because 4 does not equal 4. Well, that is obviously false. Okay. So we have equals, we have not equals, we have less than. So let's say 4 less than 2, that should be false. And then 4 less than 4. And then, oops, 4 less than 5, right? So what should be printed out here? 4 less than 2, that's false. 4 less than 4, that's also false. 4 less than 5, well, that is true. Let's run that. There you go. False, false, true. Okay. So you have the less than. You also have the greater than sign. A lot of your normal mathematical operations that you should be operators they should be familiar with. Let's say that. We should actually get the opposite, right? 4 is greater than 2. Well, actually, not the exact opposite. 4 greater than 2 is true. 4 greater than 4 is false. 4 greater than 5 is false, right? So it should be true, false, false. And there it is, true, false, and false. Okay. We also have the less than or equal to, less than or equal to, less than or equal to. Let's run through those. 4 less than or equal to 2 is false. 4 less than or equal to 4, that is true, because 4 is less than or equal to 4. That is true. 4 less than or equal to 5, true. So what do we have? We have false, true, true, right? There it is, false, true, true. And then, of course, the final one we really have is the greater than or equal to. Works in the exact way you would expect. So it should be false, true, and true, right? Excuse me. That should be true because 4 is greater than or equal to 2. That should be true, true, false, right? Let's run it. Sure enough, true, true, false. Okay. So those are what we call our Boolean expressions. Again, we can compare equal to, compare not equal to, compare less than, we can compare greater than or equal to, we can compare less than or equal to. Those are comparisons we can have. Okay. So in conjunction with those, we have what we call the logical operators. We have what we call and, and, or, and not. Okay. So how is and? Let's say we want to compare two things together at the same time. Right. So let's go back to our print. Let's say we have a number. Actually, let's get a number from the user, right? Say an x is equal to the int of the input, enter a number, right? So x will be the integer value the user types in at the keyboard. So let's figure out, is that number between 10 and 20? Inclusive. So it can be anywhere from 10 all the way up to 20. Okay. So how do we do that? So we could say, is x greater than or equal to 10? Right. So what happens if we do that? All right, let's run it. Enter a number. Let's say we enter 9. It's going to return false, right? Because 9 greater than or equal to 10 is false. Okay. If we put in 10, oops, it's going to be true because 10 is greater than or equal to 10. So that is true. Let's remember that we want to say true if x is 10 less than or equal to 20. Oops, x less than or equal to 20. If you kind of remember this notation from probably middle school or something. So that means x, I want x to be between 10 and 20. Okay. So far, this is really only checking if it's greater than or equal to the 10, right? So for example, if we put 500, You know, according to what we want to do, that's false, right? Because 500 is not between those two numbers, right? But we're only checking if it's greater than or equal to 10. So this will be true. And it does say true, but it doesn't meet what our intent is. Our intent is we want it to be greater than or equal to that, or less than, and less than or equal to 20. So we can have these logical operators. One of them is called and. And now we can make another Boolean expression. Any other expressions we want, equal to, not equal to, less than, greater than, so on and so forth, right? So what would we put here to make sure that x is less than or equal to 20? We've already done x greater than or equal to 10, right? X greater than or equal to 10. Now we need to check if x is less than or equal to 20. And we do it just like you think we would, x less than or equal to 20. Let's save it and run it. Now if we put in 9, that should be false, right? Indeed it is. If we put in 10, it's true. Put in 15, oops, put in 15, it's true. If we put in 20, it should still be true. Now if we put in 21, it's now going to be false. And if we put in that 500 from earlier, it's going to be false. And that's because it's doing both of these comparisons. It's saying both of these have to be true. That's what and is. It means this and this have to be true for it to be true. For example, if one of these is false, then the whole thing is false. And we know that because, when we put in the number 500, 500 greater than or equal to 10, that is true. This part is true, but this part is false because we're saying 500 less than or equal to 20, that's false. So we're saying true and false. And with that, the whole thing is false. Both of them have to be true for the whole thing to be true. That's the and. The other operator we have is called or. It works similar to and, except this or this must be true. Then the whole thing is true. So with and, both have to be true. With or, either one of them can be true. Okay. So let me change this up a little bit. Let's say it's true if x is see, if x is less than 0 or x is greater than 10. I don't know. So let's start off with the first part. If x is less than 0. So let's just do the first part. Let's get this one. True if x is less than 0. All right, let's save it. Of course, this is going to work just like you think it would. We put in 1, it's false. We put in 0, it's still false. We put in -1, it turns true, right? Because x is less than 0. But here we want to say, or x is greater than 10. Well, let's put in 500. According to what we want, this should be true, because I'm saying if x is less than 0 or if it's greater than 10. 500 is greater than 10, but right now it's still going to tell us false because we haven't taken that into account in our check here. So we can use the or keyword, or x is greater than 10. It's that easy. So let's run that and enter a number. So if we enter -1, that should be true, right? And it is true. Why? Because -1 is less than 0. Remember, we only need it when we have or, only one of these needs to be true. Okay. Conversely, we can put the 500 back in, and that is now true. And that's because this part becomes true. This part is false, but this part is true, so the whole thing is true. The only time the whole thing is false is if both of these are false in an OR statement. So if we put in the number 5, that's going to be false. And that's because we're saying 5 less than 0, that's false. Or 5 greater than 10, that is also false. And so that means the whole thing is false because both of them are false. Neither one is true. That's how the OR works. The final one we have, it's not used nearly as much as the AND or the OR because you can replicate it various ways, but we have not. What we mean with not is we have keyword not, and then we put in one of our expressions. Let's say x less than 4. So here we're saying, x less than 4. So we're saying, first make this comparison, x less than 4. If that is true, the not turns it into a false. If x less than 4 is false, the not will make it true. So Python will evaluate this to true or false. The not turns it into the opposite. Let's save it. Let's run it. So if we put in the number 1, what happens? 1 gives us false. And that's because we say 1 less than 4. That is true. The not reverses it, changes it into false. And that's what we get. Of course, if we put 500, that's going to be true. Because we're saying 500 is less than 4, which is clearly false, but the not reverses it into being a true. The reason why I say it's not used that much because, we're just looking for a number that is greater than or equal to 4, right? That's really what that's looking at, because if we put in 1, it's false. We put in 2, false. 3, false. 4, true. 5, true. 500, true. So what this is really doing is just trying to figure out if a number is greater than or equal to 4. So we're saying if it's not less than 4, that means it is greater than or equal to 4. So you could replicate exactly this by saying x greater than or equal to 4. Both of these effectively do the same exact thing. That's why the not is used at times, but really it can be replicated using just Boolean expressions. The and and the or you should see probably a lot. Those are extremely useful. The not has its uses, but it's not nearly as prevalent. Okay. So why do we need this? Why do we need this true or false? Why do we need to know if something is true or false? And we need to know it because what we call conditional execution, right? That means sometimes we want to execute some code and sometimes we don't, right? And we do that with what we call if statements. And they look like this. We can say if this Boolean expression is true, colon, execute this code. And this is kind of pseudocode here, right? So if whatever this expression is, if it's true, we want to execute this code. If it's false, then we just completely skip over the code. So let's say we want to do something. Actually, let's get input from the user again. We'll say x is equal to an int input, enter a number. Okay. So I have the user type in a number that'll be in the variable x. So let's say we want to do some kind of code only if x meets a certain condition, right? So let's make up a scenario here. Checks if user is old. I'm old, so this doesn't bother me. Right. So let's say anyone born before 1990 is old. You know, how old does that make somebody? If they're born in 1990, it makes them like 31 years old. Yeah. If they're 31 years old, actually, if they're 30 years old or older, let's just call them old. All right. Arbitrary number I picked, but let's go with it. All right. So it checks if the user is old. So instead of enter a number, let's enter your age. Okay. So now we need to check, is their age old? So what Boolean expression checks if user is old if they are 30 years or older? That's what we're trying to do here. So X will get how old they are from them on the keyboard. Then in our Boolean expression, we need to check if their age is 30 years or older. So we have X, actually, let's change this to age, it's more descriptive. So if the age is greater than or equal to 30, and then we have to use this colon right here. This colon is very important with the if statement. The if statement is saying if this is true, we have to have the colon here because this is saying this is a if statement. That's what it looks like. Then under here, we have to make a tab. Tabbing and spacing is very, very important in Python. Whenever we have a tab over, that means this is the code I want executed if this is true. So if this is true, we're going to just print you are old. Okay. And then we'll print another statement here, end of program or something. All right. You'll see why I'm doing this so we can see what's going on. So what will happen here, we'll get our age input from the user. We're going to say if their age is greater than or equal to 30, then we're going to print out you are old. And then at the end, we'll print out, end of the program. And as I mentioned, this indentation, this tab is very, very important. It has to be there. And that's because that's how Python recognizes what commands are part of your conditional execution. So let's make another one, print line 2. Just something so we can see where it's at in the program. So if the age is greater than or equal to 30, it'll execute this statement because it's tabbed in. It'll execute this statement because it's tabbed in. And then since the next one is not tabbed in, this is just running the remaining portion of the program. So let's say they type in 29, right? So age will be 29. We'll say if 29 is greater than or equal to 30, that is false, right? So when it's false, it will skip over these indented lines, these tabbed over lines, and it'll go to the next line that is not tabbed. So it'll print this. If this is false, it'll still print into the program because into the program isn't one of the tabbed in statements. So let's run it and see what happens. So if we type in 29, it just goes directly to end of the program. Why? Because it skipped these two lines, these two tabbed lines, because this was false. However, when that becomes true, it executes those tabbed over lines. It says you are old, then it says line 2, then it says end of program. Well, if we didn't have this tabbed over, what happens here? Let's see what happens. So if we put in 29, it's going to print out line 2 and end of program. That's because this was false. So it'll skip the tabbed lines, but it'll start execution again at the non-tabbed lines, which starts right there. Likewise, if we put in, something that's true, that is true. So it'll print out you are old, and then it'll print out the rest of the program. So that's how if works. There's also there's more to the if. That's all there is to just the plain if. But sometimes we want to execute something if it's true and execute something different if it's false. So let's say we want to say if they're old, we want to print out you are old, or we want to print out you are young. So how would we do that? So we have if this is true, you're old, right? If you're 30 or greater, you're old. If you're not 30 or older, then you're young. Okay. So what we can do here, we can use what we call an else statement. I'm going to print it out and then we'll explain it. You are young. And then we'll print out again, end of program, right? So we can see where it picks up at. Okay. So again, we'll just get the age from the user. So we're going to say if the age is greater than or equal to 30. So if this is true, then execute this, else execute this. So what's happening is if this is true, we're going to print you are old, and then we skip this else stuff and then go to the next line of the program, which is there. So if age is 30 or older, we're going to print you are old, and then it'll skip the rest of the else stuff, and then it'll come down here. So what happens if if this is false, then it goes to the else statement and executes this. So let's see it in action. So if I enter my age as 35, let's try to move this over a little bit so we can see our code. There we go. So we enter 35. We'll say 35 greater than or equal to 30. That is true. So we're going to print you're old. And then it'll skip over the rest of the else stuff, and then it'll print out in the program. So print 35, and there we go. You're old, and then in the program. Okay. So if we put in 20 less than or equal to 30, that is false. So we go down to the else stage and execute its statements. And there we go. It says you are young, end of program. So else just means if this is true, execute this. If this is not true, execute this. And it follows the same patterns, as I said, with the indentation. The indentation is very important. Here we are. It follows that same indentation pattern, that tabbing over of your statements, where the else respects these tabbed over statements, meaning all of these get executed, all these get executed in the else. All right, let's run that. Again, 20, you are young, here we are, end of program. Okay, so that's the if else. There's one more variant of this called the else if. So we have this we have this if, we have if something, execute this, and then else. So let's say we now have old age, middle age, and young age. Okay, so let's say young age is less than 30. Let's say old age is greater than 60. Let's say middle age is everything else. Okay, so if you're less than 30, you're young. If you're older than 60, you're old. If anything else anywhere between there, then we're just going to say your middle age. Okay, so again, get the age as an input. So let's first check, are they young? So if the age is less than 30, then we're going to print, you are young. Oops. That makes sense so far, right? If they are less than 30 years old, we're going to print out they're young. So now let's check if they're older than 60. So what we want here is an if age is greater than 60. then we're going to print you are old. And how does that work? So we'll make this check. If the check is true, we print this out and skip the rest of the else and elif stuff. If this is false, it's going to come down to the next else. This is really an else if. So if this is false, it comes down to the next one. And since it's an else if, it'll check, is this true or false? So then we'll say, is the age greater than 60? If it's true, we're going to print you are old. And then we can follow it up with the else, print you are middle age. Let's get rid of all this down here. And then we'll print end of program so we know it got to the end. So let's look at it. So let's imagine what if we put it in 10? All right, let's put it in 10. What is it going to print out? It's going to print out you are young, right? And that makes sense based on what we set up here. So let's think about what actually happens in our program. So when we put in 10, we're going to say if 10 is less than 30, that is true. We're going to execute this tabbed over statement. We will skip the rest of the else stuff. And then we'll go to the next line that is not indented, which is here. So enter in 10. That's exactly what we get. It prints out you are young. Then it skips down, it skips the rest of it. Then it comes down here and prints in the program. Okay. What happens when we put in 90? Let's read through our program and figure out what happens. And let's make sure that's what our program does. So if we put in 90, we're going to say if 90 is less than 30, that is false. So it skips down to the next else. But it's an elif, so it'll do another check. 90 greater than 60. That is true. So we will execute this tabbed over statement. And since we executed these tabbed over statements, since this was true, execute this, it'll skip the rest of the else stuff and then go to the next unindented line, which is that. So if we run it, of course, it says you are old, end of program. Very rude, but true. Okay, so now let's see if we pick something middle ground, put in 45. If 45 less than 30, that is false. So we're going to come and check this. 45 greater than 60, that is also false. So we'll come down here. This is just an else statement, meaning there's nothing else to check. So we'll just go ahead and execute this. And sure enough, you are middle age, end of program. So that is how the if-else statements work. I mean, how is this useful? You can think of lots of ways this is actually useful. You can think, actually, I think part of your assignment is about movie tickets, right? You know, you charge a different movie ticket rate based on if the person is young, old, or middle age or something, right? I think that's part of your assignment. So this is kind of how you do it. This is how I'm checking if somebody is young, old, or middle age, right? So that's kind of how it relates. Imagine you're going to the movie theater and senior citizens get a discount, right? There's something like this running in the movie theater's computers to determine what kind of discount you get. That's a real world application of this, this if, elif, and else statements. Okay. One more thing I want to add about the elif stuff is you're not limited to just if, elif, else. You can have, elif. You can have lots of these comparison, do something, if, comparison, do something. This is like pseudocode type stuff here, right? there's really no limit to how many LFs that you can stuff in here in between. But you can't, for example, we can't delete that. We can't start with an LF because an LF means else if. It doesn't make sense. We have to start with an if. And then we can start doing LF, LF, LF. And we don't even have to have the else on the end. We could terminate it there with an LF. That's fine as well. So you can't start with an LF. You can't start with an else. But we can have this format here. Oops. Else do something. All right. That's fine. Okay. Last part of the content, and this is very important. I'm actually sad there's not more people on here because I guarantee every time I grade from this point going forward and all the other courses that I've done, everyone messes up the test reports until they get enough bad grades on it that they fix themselves. Okay. So let me show what a test report should look like. And the test report is very important. So let's look what a test report should look like. Now, granted, your assignments tell you to do these in Word documents and stuff like that, or in a PDF. And that's actually how I want them. I don't have PDF on this computer I'm working on right now. So I'll kind of show you the outline of what it looks like using a little bit of ASCII art. But it'll at least show you what needs to be in the test report in order to get full credit on your assignments. So first of all, what is a test report? A test report is really a validation that your program is working correctly. Okay? It's a validation your program is working correctly. For example, actually, let's first do a little program that has an error in it. Okay? Actually, no, we'll make the test report in our comments, and then we'll see why it's useful by making a little program for it. All right, so the test report has several columns. One column is the test case number. Another column is our input. Another column is our expected output. Another column is our actual outs, O-U-T, P-U-T. And the last column is the result. Let me expand that out a little bit. Okay. So those are like the columns for our test report. And then we'll have a table. And the test cases will just be in orders. Test case 1, test case 2, test case 3, test case 4. Okay. So before I do the rest of it, let's think about a little program. Let's say we want to have a program that calculates the area of a square or an area of a rectangle. Okay. So our program is to calculate area of rectangle. So let's get the, so the area is equal to the length, times the width, right? That's just math. Okay. So let's make a program to calculate the area of a rectangle. So let's get from the user the length, input, enter length, and we'll get the user to input the width. Okay. Enter length, enter width. And then we'll calculate the area equals the length times the width. And then we're going to print out area is area, right? So before we even run this, let's do our test table. And we really should fill it out before we even run our program. So imagine if we run this program, what are our inputs to the program? Well, the input is the length and the width of the rectangle, right? That's what the user is going to input. So let's imagine the user enters 2 and then 3, meaning this is the length, this is the width. Let's say in another one, we do 3, then 2. In another test case, we do 4 and 10. And in our last test case, we'll do 1 and 7. Okay, that's our input. So what do we expect the answer to be, right? Without running our program, and this is very, very important, the expected output should be something that you manually compute. When I say manually, you can use a calculator. A calculator is fine, but you do not run your program to calculate this answer for you, and we'll see why here in a minute. So what do we expect the output to be if they type in 2 for the length, 3 for the width? Well, we know that should be 6, right? Because the area is the two numbers multiplied together, and 3 times 2 is 6. Excuse me, 2 times 3 is 6. Same thing here. Actually, let's make this something more complicated. 123 times 321, whatever. 3 times 2, we expect to be 6. 4 times 10, we expect to be 40. What is the expected output of this? I don't know that multiplication off the top of my head. So I'm going to use the calculator here on my desk. And for my calculator, I'm going to say, well, what is 123 times 321? The answer to my calculator tells me that is 39,483. Right? So this is what we expect the output to be for our program. This is our test case number. This is what we're going to input to it. And this is what we expect it to give us for the answer. So at this point, we can go ahead and run our program. And in the actual output, we're going to write down what is the answer that my program told me. So let's run it. Let's put in 2 and 3, and it tells me the area is 6. Okay, so for the actual output of my program is 6. Let's do the next one. Next one is 3 and 2. 3 and 2. My program tells me the area is 6. Okay, that is what my program output. Then we have 4 and 10. 4 and 10. It tells me the area is 40. Let's record that in my table. And then let's do the big one. 123 and 321. It tells me the answer is 39,483. Over here, 39,483. So for the result column, is the actual output the expected output? So are these the same thing? Is 6 and 6 the same thing? That's true. 6 and 6 the same thing? That's true. 40 and 40? True. That number is true. So when the result for all of them is true, that means our program functions properly, because what we expected it to give us for the answer is what we actually got for the answer. Okay. Now for this case, it may seem trivial, and it kind of is trivial, but when you start to have more complicated computations, you start to worry about maybe there's a bug in my code. Okay. Let's say for some reason, let's take these results and actual output back off of here. And let's say I accidentally had a bug in my program. Instead of length times width, I accidentally put length plus width. Either, maybe I just accidentally hit the plus key instead of the multiplication key. So we know this is a bug in the code because we know this is not how you compute area, right? We know it's length times width, but we made a mistake. And as you see on the news all the time, or in programs all the time, when a program crashes or a program does something wrong, it's a bug in the code. There's bugs in almost every piece of software out there, but this is a bug in our code because this is incorrectly computing the area. Okay. But for our test report here, all of this is still what we want to put in. These are the test cases. This is what I'm going to type in. This is the input I'm giving it. I expect these to be the answers. Why? Because I manually computed those, and that should be the area my program gives me. Okay, so let's run the program and see what the actual output is. All right, so let's run it. And we got 2 and 3. Oh, excuse me, I didn't save it. I got to save it. Now let's run it. There we go. Now 2 and 3. It gives me the area is 5. Let's run the next one, which is 3 and 2. Gives me the area is 5. The next one is 4 and 10. Gives me the area is 14. And the next one, 123 and 321, it gives me the area is 444. So then we go in here and we examine these. Are they the same thing? This is false. 5 and 6 are not the same thing. That's false. That's false. And that is false. All right. Actually, let's add in here for a second. Test case is 0. Well, if we put in 2, 2, for 2, 2, for length and width of 2, we expect it to be 4, because 2 times 2 is 4. Let's save it and run it. 2, 2 gives the area is 4. So this is actually true. So how does that work? Well, it just so happens to turn out, because of math, that 2 times 2 is the same thing as 2 plus 2. So even though our program, on this first test case, even though the program gave us the right answer, true, there's still a bug in the program, because even though it was true for this test case, it's false for the rest of the test cases. So that means there's a bug in our code that we need to go back and fix. And that is the single greatest key. The most important thing to a test report is it'll help tell you if there is a bug in your program that you need to fix. So because these results ended up being false, that means there's a problem in my program and I need to go fix it, right? So then I can go back and review my program and be, oh, I have a bug here that I need to correct. And after I correct it, I need to go back in and run my test report again to make sure everything turns out to be true. Okay. That is the importance of a test case, excuse me, of a test report. And this is what your test report needs to look like. Now, as I said, throw it in a Word document or throw it in a PDF and make it into a table and stuff like that. But this is the contents of what your test report need to look like. If it does not have all these columns, then you're going to get points deducted. If you don't include the test report at all, you're going to get points deducted. Okay. Now, here's what I've seen in the past. Okay. Here's what I've seen in the past. So let's say we have this test report. Let me just take out a couple of the lines to keep it shorter, so I have to do them all. Keep the example shorter. Okay, so let's say we have this right here. So I'm the student and I'm going to be lazy, right? Let's say I still have this bug in my program. Okay, I still have that bug, meaning I'm doing addition instead of the multiplication I should be doing. So let's say I have this bug. So I want to be lazy. I'm not going to go manually compute these. So I'm just, whatever my program tells me, this has to be right because I don't make mistakes, right? So let's run it. I do the first one, I put in 2, 2. It tells me the answer is 4. So my expected is 4, my actual is 4, and this is true. Let's put in the next one, 2, 3. Reminder, this is what you should not be doing, and I'm illustrating it. So you put in 2, 3, it says the answer is 5. So I expected 5, I got 5, the answer is true. Let's put in the next one, 123, 321. It tells me the answer is 444. So I put in 444, I expected, I got that, and that's true. What is the mistake I've made here? The mistake I've made here is I assumed my program was correct. It's not, but I assumed it is. So instead of manually computing what the expected output should be, I just looked at whatever my program told me has to be the right answer. And so I'm just going to be lazy and put that as the expected output and the actual output. And then they always match and being true. But this is obviously wrong, right? This whole test table is wrong because the expected output of this should not be 444. The expected output should be whatever these numbers are multiplied together, which was the 39,000 and something, right? So I'll tell you, I see this all the time. And when I see this, I will give you 0 points for your test report. Even if you've got all this stuff filled out, if you do this, I will give you a 0 for the entire test report. And the reason is you have defeated the entire purpose of a test report. The entire purpose of a test report, again, is to find bugs in your program. It's to validate whether your program is correct or not. So when you just blindly take the output of your program and label it your expected output, I know you have not manually computed it. Because if you would have manually computed this area, you would have not gotten that for the answer. It would not match your actual output. So when you do this, it clearly shows me that you've just bypassed the entire purpose for a test report. You've only copied what your program displayed and said that was your expected output, but that's clearly wrong. So do not do this. Your expected output should be manually computed, meaning 2 times 2 is 4, 2 times 3 is 6. This was like 39,824, I think is what it was. Actually, let's manually compute it to make sure we're not taking a shortcut. It's actually 39,483 according to my calculator. That is what you should be doing. Of course, these turn out to be false now. And so when I see false, I know there's a bug. I need to go fix it. So in your test report, you should never really be turning one in with a false. And that's because if you see false, you need to go fix it. Because if you just turn in this code, this is all well and good. And actually, I'll give you full credit for your test report because your test report is correct. But I'm going to have to take off points for the program because the program does the wrong thing. The program has a bug in it. So when you're doing your assignments and when you get a false in your test report, you need to stop what you're doing for a second and look back at your code and figure out where you went wrong and fix it. And once you fix it, then you go back through your test report again and run the test cases again. Okay, so that is all the material for this week. What I'm going to do a quick example of something that is kind of like your assignment. Obviously not the exact same. I'm not going to give you answers, but I'll do an example that's kind of like your assignment that you may be able to build off of in order to complete your assignment correctly. So for your assignment, I believe is it the movie tickets? I looked at it earlier again to remind myself. Yeah, it's the price of a theater ticket. Okay, that's what you have to do for your assignment. So what we're going to do for the example, let's compute the amount of taxes that you have to pay on a car you just bought. It can be a new car, it can be an old car, it can be an electric car, it can be a gas car. So let's say the taxes are 10% of purchase price plus a $500 surcharge if it's a gas car. Okay, so let's say we can have cars can be gas or electric. Kind of that's our little bit of our pseudocode. So the taxes are 10% of the purchase price plus a $500 surcharge if it's a gas vehicle, and then the cars can either be gas or electric. So what do we need to ask the user? Well, first we need to know what is the purchase price, right? So let's ask the user, purchase price is equal to, we'll just leave it as an integer. Input, enter purchase price. So we'll just have the user enter the purchase price, and let's just print it right back out. Let's test this a little bit at a time. So we'll just print out the purchase price. So we save it. If we run that, enter the purchase price. I purchased it for $1,000. Okay. And then it just prints back out my purchase price. So I know I'm getting the right thing here. Okay. So let's start figuring out taxes. So the taxes, let's figure out just this part first. The taxes are 10% of the purchase price. So the taxes will equal the purchase price times 10%. Right? So let's print out the purchase price. Let's print out the taxes. Okay. Let's save it and run it. So if I purchase it for $1,234, what should be the taxes? Taxes is $123.40. And that's because that is 10% of 1,234, the purchase price. Okay. So far, so good. So now we need to say there's also a $500 surcharge if it's gas, and cars can be gas or electric. So we need to ask the user, is your car a gas or electric car, right? So let's find out what type of car. Let's call it type of car, and we'll ask the user. It'll just be an input, because let's say it'll be a string. Enter type of car. And then here, we're just going to print out the type of car. So we're not computing it yet. We're just going to print it out, see if we get what we get. So we purchased it for $1,234, and type of car is gas, right? So again, we do print out type of car, which is gas, and then we still print out purchase price and taxes. That's it. Let's print this out. Actually, do make it look nicer. Purchase price, PRICE. We'll print out the purchase price, and then we'll print out TAXES. Make it look nicer. And then we'll also print out the type. Type of car. Let's take away this type of car for a second. So let's just run this. See what we get. Your purchase price $1,234. The type of car, it's a gas car. So then it's going to tell us the type is gas, the purchase price is this, and the taxes are this. So far, so good. So we got the type of car, but we haven't factored in this $500 surcharge if it's gas. So we need to figure out, is it a gas car or not? So what have we learned today? We can say if the type of car equals gas. So if it equals gas, then we want to execute whatever this tabbed in stuff is. So we can have the taxes is equal to the taxes plus the $500 surcharge, right? So what happens here? Enter in the purchase price. The taxes are initially 10% of the purchase price. Then we're going to ask, what is the type of car? If they type in gas, then we're going to add $500 onto the taxes. So let's see it. Purchase price, 12345. Type of car, gas. So there's our taxes. The type of car is gas. The purchase price is 12345, and this is the taxes. And that's right, because 10% of this is $12.34.50. And then we've added on the $500 surcharge to make it $1734.50. Likewise, if we put in purchase price 12345 and put in electric, then as you can see here, it's only the 10%. We had not added on that $500 surcharge. So what if they type in 12345 gas with a capital G? What's going to happen? Python is case sensitive, meaning uppercase gas is not the same as lowercase gas. So if we type in uppercase gas, we get the taxes without the surcharge. Why? Because we're checking for a lowercase gas. This is an uppercase gas, and they are not the same thing. I mean, we could put in the uppercase G here, save it, and run it. 1, 2, 3, 4, 5. Capital gas has the surcharge. 1, 2, 3, 4, 5. Lowercase gas does not have the surcharge. Well, what we could do, we could say L if the type of car equals a lowercase gas, and we can do the same thing, right? Save it and run it. So 1, 2, 3, 4, 5. Uppercase gas has the surcharge. 1, 2, 3, 4, 5. Lowercase gas has the surcharge. Well, what if we type in uppercase G, little a, uppercase S? It doesn't have the surcharge. You know, so do we add on here? Or should we put this? And then what if it's little g, capital AS? You know, how many combinations? There's a lot of combinations, right? So a thing we can do for Python, we have this thing called .toLower. I think it's toLower. I hope it's toLower. Otherwise, I'll have to look it up real fast. So type of car is a string, right? And what this is going to do, type of car is a string, and it can be any combination of upper or lowercase letters. What this does, it takes that type of car string and it makes all of the letters lowercase. So even if I type in uppercase gas, this right here will convert it to all lowercase letters. So then I can just compare it to all lowercase gas. So I run this, 1, 2, 3, 4, 5, lowercase gas. Oh man, maybe it's just lower. Sorry, I do a lot of different programming languages. Yep, there we go. So if I type in a lowercase gas already, it has a surcharge. If I type in an uppercase, oops, price first, uppercase gas, it has a surcharge. If we type in GAS, it has a surcharge. If we type in 2, 3, 4, 5, GAS, it has a surcharge. And that's good, because no matter which uppercase or lowercase letters I typed in, this will convert them to lowercase so that we can compare it to just the lowercase gas. So that's how we added in the taxes, the surcharge, if it's a gas car. Okay, so that's the end of the example. It's, like I said, fairly close to what you have to do for your assignment. You take this, modify it to be what you need it to be. All right, and that's the end of this week's materials. So I'll open it up if you have any questions. All right, I only see one person still in the room, so I'll wait about 1 more minute or so, and if you don't have any questions, I'll go ahead and wrap it up. And I will be putting this up on YouTube, and I'll get the link sent out. So standing by 1 more minute. All right, I'm going to go ahead and end this, and I'll get it put up on YouTube and get the links out.